Okay, as you take these notes, make sure you have some paper with you. You'll be uploading these later to Canvas. So as we begin, we're going to talk more about quadratics and their graphs and solving them. So first of all, you need to know that this quadratic would be in standard form. So in standard form, you're going to have the x's in descending order, and the 2 is going to be your highest degree when you're solving the quadratics. So make sure that you understand that the highest exponent in a quadratic is a 2. And make sure you understand that it needs to be in the correct form before you start looking for your A, B, and C, because sometimes that will mess you up. Now, the very first part of the quadratic formula is negative B, and then it's over 2A. That's going to help you find the vertex of a quadratic in standard form. So let's talk about, first of all, what a vertex is. So if you have a quadratic, it can open up or it can open down, okay? So as you draw these, this one right here that I'm drawing is going down. This one here that I'm going to draw is going to up. So when you're looking at a parabola, when I'm saying up, it means that your A is going to be positive. So if your A is positive, the parabola is going to open up. Your vertex is going to be this low point right there. That's going to be your vertex of the parabola. It's called like a turnaround point because it's where your parabola will either go from increasing to decreasing. So when you notice it's decreasing here, and then it turns around and goes back to increasing. This time your vertex is your highest point. So it's going to go from increasing, and then it's going to go to decreasing. So it's where your parabola is going to turn around at. So if A is positive, it's going to open up. If your A is negative, it's going to open down. Okay, so if A is positive, it's going to open up, just like a positive person. If A is negative, it's going to open down, just like a negative person. So when you're looking at your A is going to be the leading coefficient. So it's going to be the leading coefficient because it is the leading number in front. Okay, so if it is positive, it is going to open up. If it is negative, it is going to open down. Remember, your vertex is a turnaround point. So that means this needs to be a point, which signifies it's an ordered pair. So in order to get the y coordinate, because that's going to be your x, to get the y, you have to plug the x in to your quadratic. So whatever you get for your x is going to go everywhere in place of your x. So notice if I was to get this number to be maybe 4, it would go everywhere there is an x. Once you have plugged that in, you're going to get a value, and that will be your y. So in order to get your y, you have to substitute your x. So whatever that is, you need to substitute it in place of x. Okay, so let's think of some definitions. First of all, We went over vertex. It's going to be an ordered pair. It's going to either be your highest point on the graph or your lowest point on the graph. So if you go back, this point and this point, those would be your vertices for those. The axis of symmetry, it is going to be a dotted vertical line that cuts the parabola in half. So the graph of a quadratic is a parabola, okay? So when you think about the word quadratic, you can see the U. A parabola is a U-shaped curve. So a parabola is a U-shaped curve. And the axis of symmetry is going to cut the parabola in half, which means the points on each side would be symmetrical. So if I had an axis of symmetry, it would go right through the vertex, and it would cut the parabola in half, where the points would be symmetric on each side of that axis of symmetry. Now, the axis of symmetry is always going to be x equals, and it is going to be the negative b over 2a. So it's going to go right through your vertex. That is where your axis of symmetry would pass through. So when you go back and you think about the axis of symmetry, it would go straight through the vertex. And remember, a vertical line is always x equals. So when you look at this again, that's going to be a very good definition to remember, because that is going to be your axis of symmetry. The y-intercept is where the parabola touches the y-axis. Now, if it is in standard form, remember that to find the y-intercept, you're going to replace x with 0. So you replace x with 0, and you're trying to find your y value. So if you think to the standard form, and you put 0 in for your x, this would go away, this would go away, and you would be left with your c. So whatever that number is, your constant number, that's going to be the y-intercept. So with a quadratic, it would be 0, c. That would be where the parabola would touch the y-axis. Okay? To find solutions, roots, zeros, and x-intercepts, this is where the parabola would touch the x-axis. So when you're looking for where the parabola touches the x-axis, you're going to replace y with 0 and solve for x. So you remember when we was solving for x, we was using some different methods. So one of the methods that we used when we set it equal to 0 was factoring. That helped us find our x-intercepts. Another method that we used was the quadratic formula. You know, we set that equal to 0 to help us find our x-intercepts. So those are some things when you're thinking about that will help you. I would always first try factoring. And if factoring doesn't work, then go to your quadratic formula. And both of those forms, you're going to replace y with 0 and solve for your x. Now remember, the most x-intercepts you're going to have with a quadratic is 2. Okay, so when you're thinking about a quadratic touching the x-axis, so if it's curving down and coming back up or vice versa, the most it's going to touch is 2 places. Sometimes it might bounce and come back up, so it might only have one solution because that solution might be a repeat. So it like touches and bounces and doesn't cross through the x-axis. And remember, if it does not touch at all, then it is going to have no real solutions, but you would have 2 imaginary. So again, these would be the methods that you would utilize to help solve for those. So as we talked about earlier, if A is negative, the parabola, both ends are going to go down. Now, if that happens, it's like throwing a ball up and it's going to reach a maximum height. So that's going to have a maximum value. Now, the maximum value occurs at the y coordinate of the vertex. So when you're looking for your maximum height, you're going to look at your y to see how high that ball went. So if this ordered pair was, we would say 250, we would say maybe after 2 seconds, the maximum height of the ball would be 50. So this would have a max at 50. So again, you want to look at your y value, and if it opens down, then it has a max. Now, if your parabola is positive and both ends go upward, that's kind of like jumping into a swimming pool. You would reach a minimum before you come back up out of the water. So as you jump in, you would reach a depth before you come back out. So if this was to say, we'll say after 1 second, you might be 6 feet below. So when you look at that, your minimum is going to be the y coordinate of the vertex. So make sure that you pick your y, like we mentioned. So it'll be your y coordinate. And this would have a minimum at -6. So sometimes the questions will ask you, if a parabola opens upward, what is your A? So you do need to kind of know that your A would be positive. It might ask you if this problem has a max of 50. Is your parabola going to open up or down? And you would know that goes down because your A is negative. So when you're looking at your up or down for your parabolas, make sure you look at your ends, okay? The ends of the graph. Both of those are trending toward negative infinity. So both of those ends are going down. Okay, both ends should be going in the same direction. So if you notice this one, both ends are going up, so they're both going to positive infinity. So if you're looking at whether a parabola is increasing or decreasing, you're only looking at one side of the parabola. So the first thing that you're going to try to look at is you're going to look at the graph, okay? Then after you look at the graph, you're going to read the x-axis for your increasing and decreasing. Remember, when you read your x-axis, these intervals are going to be open intervals, so do not bracket those. So if I'm looking at a parabola and I'm looking at one that is opening downward, the only side of that parabola that is increasing is that left side, okay? When I'm looking at a parabola and it is increasing and the parabola is opening upward, I would be looking at the right side of that parabola. So when you see that the axis of symmetry goes through that vertex, you can see when I was talking about this part of the graph would be increasing from left to right, and this part of the graph is increasing from left to right. So when you're looking at that graph, make sure that you're looking from left to right. So when I'm looking at this one, this would be decreasing from left to right. And then this side over here of this opposite one would be decreasing from left to right. Okay, don't look at the arrow when you're looking at increasing and decreasing. You're looking at the graph from left to right. So this is going down and that is going down. Okay, so make sure when you look at the graph, you're going from left to right. Okay, and you're going from left to right. Now, once you figure out that, you are then going to look at your vertex to figure out the increasing and decreasing intervals. So we'll say this is my x-axis, okay? And we'll just say this vertex is at 0, 0 to keep it kind of the same with all. So this would be increasing from negative infinity to 0. Okay, so if I come back over here, this would be decreasing from 0 to infinity. Remember, you're looking at your x-axis when you're doing those. This is where some of you got a little confused, but you're kind of coloring that area, if you remember. And so this graph would be increasing from negative infinity to 0, and it would be decreasing from 0 to infinity. Then when you come to the other graph, we'll put this at 0, 0 as well. This is increasing from 0 to positive infinity. Okay, we'll go ahead and put this one at 0, 0 as well. So on this one, I shouldn't have drew the thing on the other side because it was up top. So just erase that part if you did that. I'm sorry. So on this one, it would be decreasing from negative infinity to 0. So that would be decreasing when your x's are negative infinity to 0. It would be decreasing when your x's are between 0 and positive infinity, because remember, you're looking at your x-axis, okay? Up here, it is increasing when you are going from 0 to infinity. You're looking at your x. This one is decreasing when you're going from negative infinity to 0, okay? Now, the new forms that we haven't taught as much about are called vertex form and intercept form. Sometimes this form is referred to as factored form. So it might be intercepts or factored. Now, we did talk a little bit about vertex form when we did the shifts. So if you remember, the A affected the size. So we talked about that when we did our transformations, that A affected the size, and it also affected the direction. If you remember that the H, that was your horizontal change. And remember, if it was plus, it went to the right. And if it was minus, it went to the left. That affected your horizontal. So what we did to find those is, if you remember, we set this equal to 0 and we solved for x, and that gave us our horizontal change. The K was your vertical change. And if it was positive, it went up. And if it was negative, it went down. So make sure you're taking good notes, especially if you forgot this information about the vertex form, because it's going to come up again. So when you notice, if it's, you look at the absolute value of that A to tell the size. So if it's a 1, it's going to be normal. Now, if the A is negative, it's going to open down, okay? That's why you look at the positive of that number to tell you about the size. You don't look at the negative of the number to tell you about a size. So if that number is bigger than 1, the absolute value of that, then it's a stretch because it's going to get skinny. If it's between 0 and 1, the absolute value, like 1/3, it's going to be a compression. So it's going to get wider, okay? So remember, the direction is up or down. So you have to look at the sign, but you do not look at the sign for the size. So the A is going to tell you 2 things about the graph. Now, when you go to intercept form, the intercepts is what would go in for your P and your Q. So if you were to have, let's say that we have a parabola that's going to touch at 3 and -3. Okay, and let's say that my A is 1. So my A is just going to be 1. So if I was to plug that in, and the A is 1, I would do x minus, and I would put in the -3. Then I would do x minus, and I would put in the +3. So the double negatives are going to go to plus. So it's really going to be like x plus 3 times x minus 3. So you can notice here, if I wanted to go from factored to standard, I would FOIL this. So I would get x squared. The outside and inside are going to cancel. So it would be y equals x squared minus 9. So the -9 would be the y-intercept, because that would be your C. So it would be way down here. Okay, and then you would be going up through the -3 and the +3. And that would be your x-intercepts. So that would kind of be how you could go from your factor to your standard. Your B would be missing in this case, okay? That's why if your B is missing and you're trying to find your solutions, you can put a 0 in for that to find your x, and then you can use your square root property. And some of you are forgetting this when you take the square root to put your plus or minus. So that would be your two answers, plus or minus 3. And that would be where it's touching your x, okay? Okay, so we're going to go through this question with a lot of the information that I shared with you. So the first thing you want to do is make sure that you have your quadratic in standard form. So since we do, we're going to identify the A, which is 1, your B is -2, and your C is -8. Now, the first thing as you go through is you want to try to find the vertex of the parabola. So you want to use the first part of your quadratic formula, which is -b over 2a. So as we plug that in, you want to put your negative, and then you're going to plug your b in. You're going to put your 2, and you're going to plug your a in. So b is -2, and your a is 1. So that is going to go to a +2 over a 2, which gives us a 1. So as we get that number, that is going to be your axis of symmetry, x equals 1. Your vertex, that is going to be the x of the vertex, which is going to be 1. The vertex is an ordered pair. So what we're going to do now is we're going to go back to the original function, and we're going to plug in the 1 to get the y, because we have to make a substitution. So I'm going to put a 1 in for x. Then I'm going to go through and do the order of operations. So that's going to be 1 minus 2 minus 8. So then I would get -1 minus 8, which means we get a -9. So the vertex of that parabola would be 1, -9. Okay, so what that means next is we can go ahead and try to graph that point. So I'm going to go ahead and plot 1, -9. So the axis of symmetry is going to run through the vertex, and the vertex is going to be at 1, -9. So that means that you want to pick some points on each side of the vertex to get your graph. So I'm going to put the vertex in the middle of my T-chart, and I'm going to try to go in order with my x's. So this would be like a 2 and a 3, and this would be like a 0 and a -1. Okay. Now, if you remember earlier when we was talking about your y-intercept, if you were to put 0 in, all of those would go away, and your y-intercept would be -8. So we would go to 1, 2, 3, 4, 5, 6, 7, 8. So your y-intercept would be at 0, -8. Okay, so when you're plugging these numbers in, you can plug each of these in individually. You could go through and type this in to your calculator and type the entire function. So we would have x to the second minus 2x minus 8. And when you go to your T-chart, you can see right here the points that I found. So we can also go to -1 and get the -5. So I'll go over here to -1 and get -5. Okay, so what you can know about your axis of symmetry is the points on the other side are going to be symmetric. So for example, if you have that as the vertex that negative 8 is going to match up with your 2. So your 2 is going to give you a negative 8 because it's going to be right across from the other point. Okay. Your 3 is going to match up with your negative 5, which would be directly across from your negative 5. 2, 3, 1, 2. Yes, right there. Okay. So when you look at that, we kind of have an idea that this parabola is going to be going upward, but we need to figure out what our solutions are going to be. Okay. So when we're thinking about the solutions, and I go back to the original problem, to get the x-intercept, I'm going to put a 0 in, and I'm going to try to factor first. So I'm going to ask myself, does anything multiply to give me negative 8 and add to be negative 2? So that would be negative 4 and positive 2. So then I would set those equal to 0. And the two answers that I would come up with would be 4 and negative 2. So when I go over to my graph and I put a point at negative 2, and then I will put a point at 4. That is where the parabola would touch your x-axis. So right here would be a solution, and right there would be a solution. Okay, so if you are thinking about, trying to go back now and do your increasing and decreasing for those intervals, we would notice, first of all, that this side of the parabola would be decreasing. So it would be decreasing, and you would look at your x's. So it would be decreasing from negative infinity to 1. Then on the other side, it would be increasing from 1 to infinity. So the axis of symmetry is going to split those two regions apart for you. Okay, so when you're thinking about this one, we do know that it opens up. Okay, so your direction would be up. We also know that it has a minimum since it opens up, and the minimum is going to occur at negative 9. That's going to be your lowest point of that graph. Okay, now if you go back and you think about putting this into your vertex form, if I write that formula down, okay, we know that our A is 1, x minus. So this is the vertex. So it would be x minus 1 to the second. The k is your y. So that would be your minus 9. So your vertex form would be x minus 1 to the second minus 9. So if you remember, the vertex, that inside is going to be opposite and the outside is the same. And when you compare these parabolas, if you forgot, your parent function to a quadratic is y equals x to the second. So your parent is y equals x to the second. So in your parent function, remember, if we had negative 2, it gave us 4. Negative 1 gives us 1. 0 is 0. 1 is 1, and 2 is 4. So if we had our parent right here, you're able to see that what happened was this parabola went to the right 1 unit. So it went to the right 1, okay? And then it went down 9. So it went to the right 1 and down 9. That would be your changes. So the last thing is remember that your domain, you can put any number in for x. So it's negative infinity to positive infinity. But your range is what you get out. That is your output. And if you notice right here, that is your lowest value because -9 was your minimum. So after that point, your y's get bigger. You do want to bracket your -9 because -9 is included. Remember, your infinities are never bracketed, okay? I hope you learned a little bit more about the parabolas and also about how to graph those and find the solutions. Again, if something doesn't factor, always go back and try your quadratic formula.